In today's session, we are going to learn about the nature of the roots. What if I told you that just by looking by one part of the quadratic equation, you can predict the nature of the roots? Is it possible? Let us try to see in this video. Hi, I'm Syed. Welcome to my channel Educate with Syed. Let's get started. Let's consider the quadratic equation ax square plus bx plus c is equals to 0. And the root of this quadratic equation is given by this formula x is equals to minus of b plus r minus square root of b square minus 4ac divided by 2 times of a. Now to find out the nature of the roots, you need to just see under square root what is the value you have. Under this square root, the value that you are having is b square minus 4ac. Based on the value of this b square minus 4ac, we can identify the nature of the roots. So over here, three cases will arise. Let us try to see case number 1. If the value of b square minus of 4ac is greater than 0. Greater than 0 means b square minus 4ac is a positive value. So we know that square root of a positive value will always be a positive value itself. Therefore, the square root of b square minus of 4ac will be a positive value. So once you know the positive value, then the root of this equation can be written as x is equals to, let me divide each of this term by 2a. Let me split that one and write that value as minus b divided by 2a, then plus or minus square root of b square minus of 4ac divided by 2a. So since you are having plus or minus, you can separately write down x to be equals to minus b divided by 2a. So the first root I'll write it as positive value plus square root of b square minus 4ac divided by 2a will be one of the root, and another root will be the negative value minus b by 2a minus a root of b square minus of 4ac divided by 2a. So that will be the root of the equation. Hence we see that over here we have a positive value and over here we have a negative value, and both the roots are different, or we can say that both the roots are distinct roots. So whenever b square minus 4ac is greater than 0, we get distinct roots. These two roots are real and distinct roots. Since both the roots are different, therefore we can say they are distinct roots. So if b square minus 4ac is greater than 0, then we can say that the two roots are real and distinct. That is case number 1. Now let us move on to case number 2. Suppose if I take this b square minus of 4ac is equals to 0. So under this square root sign, if this b square minus 4ac is equals to 0, which means that we have a root of b square minus of 4ac is equals to, since its value is 0, square root of 0 will be 0. Then what will be the root of the quadratic equation? Let us go back to this equation. So in this equation, b square minus 4ac has become 0. So square root of 0 will be 0. What is left out? Only minus b divided by 2a. So let me write down, it is minus b plus or minus a root of b square minus 4ac has become 0. Divided by how much? Divided by 2a. So if you ignore this 0, you are left out with minus b divided by 2a. And this x is equals to minus ba will be one of the root with this positive value, say plus 0. and x is equals to, it is minus b divided by 2a minus of 0. But there is no need to write down this plus 0 and minus 0. It's just for explanation purpose, I have written this value. Therefore, we get two roots and both the roots are the same. X is equals to minus b by 2a and x is equals to minus b by 2a. So here the roots are equal roots. The roots are equal roots. Now let us move on to case number 3. If the value of b square minus 4ac is less than 0. So under root b square minus of 4ac less than 0 means it is a negative value. So square root of a negative value cannot be a real number. It is not a real number. If it is not a real number, we call this as a complex number. So if it is not a real number, then we don't have the real root. So therefore, a real root does not exist. The real root does not exist. So let me summarize. We have seen 3 cases. Case number 1, we have seen that if b square minus of 4ac is greater than 0, we have a real and distinct roots. Real and distinct roots. Suppose if b square minus of 4ac is equals to 0, we have equal roots. And the third case, suppose if b square minus 4ac is less than 0, we do not have any real roots. No real roots will exist. So this is how we can find out the nature of the roots. If you like my video, please subscribe to my channel. If you want any specific video, just put in the comment box. That's all I have for today. Thank you. Hence, we see that over here, we have a positive value and over here we have a negative value. And both the roots are different. Or we can say that both the roots are distinct roots. So whenever b square minus 4ac is greater than 0, we get distinct roots. Therefore, these two roots are real and distinct roots. Since both the roots are different, therefore we can say they are distinct roots. So if b square minus 4ac is greater than 0, then we can say that the two roots are real and distinct.